So are multiverses a thing? Well, it's an idea worth exploring. What? No, no, no. Multiverse ideas are pseudoscience. You cannot rigorously test them. Therefore, they must be rejected and are not a subject for discussion. Okay, Alpha Universe Mike, that's your opinion in your rigidly scientific universe. But in this universe, what? Nah, man, it's all good. Scientific speculation sometimes becomes science fact, and we should explore all ideas. Okay, relaxed beta universe, Mike, that may be the case in your universe, but in this universe, we're open to... We finally reached the apotheosis of this channel, me arguing with myself. I'm Mike Siegel, I'm an astrophysicist, I write for Ordinary Times, and this is The Throughput. Multiverses, multiverses, multiverses. It seems like every science fiction, fantasy, action franchise these days is engaged in a multiverse. This has really been the year of multiverses. Spider-Man first had its Spiderverse movie, and the MCU has now gone into the multiverse in a big way with Loki and the Multiverse of Madness and all the other series. Doctor Who, of course, went into it many years ago, and this year saw the release of the movie Everything Everywhere All at Once. This is a relatively new movie, and some of you may not have seen it, so I'm not going to spoil it. I'll just say it's one of the best movies I've seen in a long time, so I do strongly recommend it. I'll be talking about it, but avoiding spoilers. When we say the word multiverse, we're talking about two different concepts, one of which is more philosophical and one of which is a little bit more scientific. The philosophical one is the many worlds hypothesis, and this actually goes back thousands of years to ancient Greece. The speculation then was that multiple universes were more linear than parallel. That is, that the universe went through this cycle of same events happening over and over again with subtle differences, and we would live through the same events again and again. Now, the concept that we deal with today is the idea of parallel universes. Universes sort of stacked side by side, which are similar but slightly different. And in the strong version of that, these multiverses are created by like decision trees. You make a decision, and in one universe you made one decision, in one universe you made the other decision, and that's how these universes debauch out from that current point. There are two problems I have with this concept, at least philosophically, if not scientifically. One is, how big does the decision need to be? You know, if I decide to have the chicken or the fish on my airplane flight, does that create two different universes?
What was it we had for dinner tonight?
Well, we had a choice, steak, fish.
Yes, I remember. I had lasagna.
Now, there are two ways to approach this. One is the sort of minimalist approach that the Loki series take, where only really big universe-changing decisions create alternative universes. Most decisions are too small and cause very small deviations from the timeline, whereas a big decision, such as Loki surviving something, results in a big split and therefore a new universe created. And of course, in the Loki series, they have a time agency that's designed to trim off those decision trees and make sure that only one universe exists and that there are no other multiverses. The other is the maximalist version, and this is where we get into some actual physics. And this comes from the early 20th century when we were beginning to understand quantum mechanics. Quantum mechanics governs the interior of atoms. When you talk about things on the microscopic level, you are talking about a universe that is very different from the one we live in. Quantum mechanics is one of the most difficult classes that physics students encounter. It's not only difficult mathematically, it's difficult conceptually. We live in a macroverse where the motions and positions and existence of things is very deterministic. If I throw a ball, it moves a specific way based on the laws of physics. If I launch a rocket, it goes into a specific orbit based on the laws of physics. In the quantum mechanical realm, though, things are clouds of probability. They move faster than light. They jump through walls. They do all kinds of crazy things. Sometimes people draw parallels between the Earth orbiting around the sun and an electron orbiting around the center of an atom. But those things are wildly different. The Earth is a solid object moving in a very specific and predictable orbit, whereas the electron is less an object than it is a cloud of potential electron that only has a position and a velocity when we actually measure it. Now, mathematically, we understand quantum mechanics very well. Well, particle physicists do, I don't. But conceptually, it's still something we're working on. We don't really understand what's really going on the quantum realm. There are various schools of thought for how quantum mechanics actually works. Probably the most popular is the Copenhagen idea, and that is that particles don't actually have properties like position and spin and velocity until those are measured. What they have instead is what we call a wave function, a probability distribution, a likelihood that the electron is spinning this way or spinning that way. And when you observe it where it interacts with another particle, that's when it's measured and that wave function collapses and it actually has a spin or a position or whatever. Erwin Schrödinger illustrated this with his example of Schrödinger's cat, which you've probably heard about. And that is, you put a cat in a box with a canister of gas, the release of which will be triggered by the radioactive decay of an element, and it's got a 50-50 chance of decaying. And he said, if you follow this idea to its conclusion, then the cat doesn't exist until you open the box. It's a superposition of two states, an unconscious cat and an awake cat, and until you open the box, it doesn't exist. There are many alternatives to that, one of which is the many worlds hypothesis. And that is that the particles exist in many different states in many different worlds. Let's say you have this electron. Is it spin up or it's spin down? You actually have two universes, one where it's spinning up and one where it's spinning down. Therefore, all these universes break out from when particles interact and are measured. This is kind of a mind-boggling concept because according to this concept, there are unthinkable numbers of alternative universes. Every time some particle does anything, a pair of alternative universes is created. There are alternative universes being created in this room right now. Every time a particle of light strikes something in this room, every time an electron moves through the camera that you're watching this on, a new universe is created. That would be sort of the maximalist version of the many worlds hypothesis. So while this is mainly used as a narrative device and doesn't have a firm scientific footing, it does touch on a very complicated physical concept that physicists have been debating for over a century. Now, the second concept that I sometimes stumble upon is that these multi-universes tend to be very protagonist-centric, that their decisions affect the universe. But if you think about it, your existence is the result of millions of decisions made in the past. And in most universes, you would not exist at all. In fact, Doctor Who had this, where one of the main characters, Rose, did not exist in an alternative universe because her parents decided not to have children. If you look through your line of ancestors, you will find people who met by wild coincidences. You will find people who narrowly escaped death. We are all the descendants of survivors, all the descendants of people who got lucky. Even one changed decision in the past would result in you not existing. Now, both of these things are one of the reasons why I like the way Everything Everywhere All at Once approaches this. They have sort of a 2D representation of the different universes, and nearby universes are almost identical, where the differences are trivial. But the further you get away, the more different the universes are. And in fact, at some points in the movie, they get very far away, where humans evolve to look very differently, or humans don't exist at all. And in fact, one of the characters says, most universes are like this, where there's no people at all. And it's a really wonderful way of addressing this concept. Ultimately, though, I'm not a fan of the many worlds hypothesis, because it basically involves the spontaneous creation of matter. Whole universes created just spontaneously, all this matter and energy springing into existence from essentially nothing. As a scientific concept, I find it a very bit hard to swallow. Ultimately, when you talk about the multiverses we see in Hollywood movies, you're not talking about a scientific concept. This is more of a philosophical concept. We don't know of any way to test the many worlds hypothesis, even the one that comes from quantum mechanics, which has a little bit more rigidity to it. And so while these are interesting philosophical debates, and interesting philosophical concepts and interesting narrative concepts for movies, they don't really have a scientific background. They touch on important scientific concepts in quantum mechanics and so forth, but really nothing we can test or get in a lab. Now, there is one version of the multiverse, though, that is a little different and does actually have a little bit of a scientific basis. One of the problems that keeps cosmologists up at night is what we call the fine-tuning problem. Our universe is governed by various sets of physical constants. You have the charge of the electron, you have the strength of gravity, the strength of the nuclear force inside atoms. And if you changed any of those by even a tiny amount, our universe would be very different. In fact, life might not even exist. Stephen Hawking was one of the ones who talked about this, that if you changed the nuclear force, for example, by a small percentage, stars would be powered very, very differently than they are now. And our universe would be radically different. And in most conceptions of that, life would not be possible. Our universe would have winked in and out of existence in a moment, or expanded out and destroyed itself, or just some small change that would not have allowed stars and planets and galaxies to form and would not have allowed us to come into existence. Now, there are three ways you can sort of get around this. One of those is to invoke God or aliens on some higher plane or some mechanism that actually sets the constants of the universe so that life is created. That's a more of a religious, philosophical concept. Science can't really address that. The second one, which I'm kind of a proponent of, is that this is telling us something fundamental about the physical laws of the universe. We have various sets of theories about how the universe works, but they don't interact very well. For example, we have general relativity, which tells us how planets move and how black holes form and all that stuff. And we have quantum mechanics, which tells us what happens inside atoms. Those theories don't mesh. They deal on very different scales. We've never found a way of explaining both concepts, general relativity and quantum mechanics, with one unifying theory. That's the ultimate goal of physics, to have one theory that explains everything, but we're not close to that. If we had that theory, if we were able to form that theory, then I think this sort of fine-tuning problem might come out of that very naturally. You might say, oh, of course, that's why it works the way we do. The third idea, though, is where the multiverse comes in. And that is when the Big Bang happened, it did not create just one universe. It created many universes. Thousands, millions, zillions, however many you want. And in each one had different physical concepts. You can almost imagine them like dials on a control panel. And each time you create a universe, the dials spin randomly, and you get this charge of the electron, this gravitational constant, this strength of the nuclear force. And then another universe happens, and the dials spin again. We just happen to inhabit that one universe, or one of a few universes, that was stable enough for life to happen. Most of them, they winked in and out of existence in a moment, or they exploded out and never formed life, or gravity was so weak they're just fogs of hydrogen gas or whatever. We happen to have the universe that is stable. Now, that's a nice theory. Is it testable? It may actually be testable. There was a paper about 10 years ago that looked at anisotropies in the cosmic microwave background. The cosmic microwave background is the leftover relic radiation of the Big Bang, and it's very smooth. And what they were saying was there was this signature in it that might indicate another bubble universe crashing into ours and interacting with it. And that would break the symmetry of the smooth cosmic microwave background we see. Now, later results showed that that was not the case. It appeared to be a false signal. But that is one interesting way. You could potentially see our universe interacting with another universe and creating very different areas of space. One of the things we have in cosmology is this idea of homogeneity, that everywhere in the universe has the same kind of things going on. Everywhere has stars and galaxies and black holes and so forth. There are different structures, but if you look at it on a large enough scale, it's homogeneous. If you found some part of the universe that was different, that might be being affected by a nearby universe that had interacted with ours. Another one you may have heard earlier this year, that scientists in the Arctic detected an alternate universe and a multiverse where particles were flowing backwards. This was a misrepresentation of an actual result. Particle experiments in the Antarctic did detect particles we didn't expect, moving in directions we didn't expect. The most likely explanation is that we need to change the standard model that explains particle physics. It may also be just noise, or we're still trying to get more data to make sure we have that signal. But another remote possibility is that these are particles from another universe crossing through the boundary and interacting with our universe. And so you could detect exotic particles that come from other universes. That's very unlikely, and I should say I think that's not the correct interpretation of those results, but it is a possibility. Ultimately, I don't think we'll ever find any evidence for or against the multiverse hypothesis. It's a very interesting hypothesis that explains one of the big outstanding problems in astronomy, but I don't think it necessarily is testable, and we may never know the answer to that. But I did want to talk about that when we talk about multiverses. As for the multiverse movies, ultimately, these aren't really about science. These are about ideas. One of the things that obsesses human beings is the idea of the road not taken. The idea of some alternate life we might have lived, and what might have been those circumstances. What if I'd gone on the date with that woman back in college? What if I had gone to Georgia Tech instead of Carleton? What if I had chosen to go into radio astronomy instead of optical astronomy? How might my life have been different? Might it have been better? Might it have been worse? Would I have missed the people that are in my current life? Or would I have people in my new life that I'm missing now because I never met them, or they never came into existence? The MCU actually explored this a little bit in Endgame, when Tony Stark, when they were going to reverse the snap, said, I don't want to have us go back in time, because he didn't want to lose his daughter.
You remember, everyone Thanos snapped away 5 years ago, just bringing them back to now, today. Don't change anything from the last 5 years.
Multiverse ideas allow us to explore the idea of the road not taken. They allow writers to look at different versions of their characters. They can explore for pathos, as Everything Everywhere All at Once does, for comedy, such as in Loki, where we say, who's the one person that Loki could fall unconditionally in love with? Obviously himself. It can be explored for silliness, or for just to allow different versions of the same story to be true. Many of these comic books have been going for a long time and have occasionally rebooted themselves. And the movie franchises we've seen rebooted themselves. So like with the Spider-Man No Way Home, that allows all three Spider-Men to have existed and to be able to interact. Ultimately, these are narrative devices. Some franchises do it pretty well. I think the MCU, for the most part, has gone to it. I thought Spider-Man Into the Spiderverse was an outstanding movie. Putting aside the kind of ridiculous science that's in it, Everything Everywhere All at Once does it wonderfully, and is probably one of the best movies I've seen in the last 10 years. Ke Kwan, you may know as Short Round, came back to acting for this movie and just does this amazing performance as three different characters speaking in three different languages. And as one scene, you'll know when you get to it, that totally broke my heart. This is just a wonderful movie. Ultimately, with science fiction and fantasy, and when we talk about multiverses, we're drifting more into the fantasy realm. It's going to come down to the writing. Do I care about the characters? Do I believe the situation? Am I interested in what's going to happen? Are you using this narrative device to ask interesting questions and to look at interesting aspects of the characters? Or is this just flash and bang and we want to use cool special effects? Good movies like Everything Everywhere All at Once or Spider-Man Into the Spider-Verse do this very well. I'm glad to see that this is becoming a useful narrative tool, even if on a scientific concept. I reject all of these multiverse movies. Give us movies that are based on real solid science like 2001 and War of the Worlds. That's one point of view. I find these movies to be really trippy, and that makes me happy. Well, maybe. As usual, I'm between the middle of my alpha and beta selves of believing that this is something that can be interesting, even if it's not a valid scientific concept. Anyway, I always love talking about literally out there concepts, even if they don't have necessarily a scientific base. If you can think of another one you'd like me to explore, be sure to leave some in the comments. Like and subscribe. We'll be back in a couple weeks. I have 2 videos I'm actually working on right now. One, another TV series review, and one, a little bit of a change of pace for me that I hope you guys will like. Until I'm finished with them and can put them on this channel, I'm Mike Siegel. I write for Ordinary Times. Thank you for watching. Of various sets of physical constants.